Yeah, hello all. This is Anupama Physics from Spark Academy. So today I am going to teach about the waves and the easy tips to learn. That means the important topics which are involved in learning waves. Okay, waves actually, um, right. So we'll just go to that and then continue. Go to the PPT and then continue. Just we'll wait for a couple of minutes to everyone to join and then we'll start, right? Yeah. Yes. So we will get back to this. So as I told you, this is Anupama, and I'm from Spark Academy, and I'm going to teach you some tips or tricks regarding the waves and wave motion. Okay. So as you all know that Spark Academy is offering many different courses on NEET, IIT Foundation, Mains, and EAMCET. So please download our app and get some discounts on the different types of courses. And you can see here, like we have a different, I mean, as I told you, many different courses are offering, and then every course has its own sessions, morning and evening sessions we have. And even if any student misses the class, they can have this uh, the videos, I mean recorded videos are always available in the app, and even if they miss, they can watch the videos later when they get time, right? So this is about Spark Academy, and you can see here the progress of the start Spark Academy. Like we conduct every week test, and the test analysis will be given immediately. And we usually every day, on everyday basis, we give assignments online to the children so that children can do their assignments and submit online. And even there will be a follow up even if a child misses his or her assignment. We will call the child, we'll make the child to do the assignment, and we'll just counsel them to counsel the child to know, I mean, the importance of doing assignment here. So this is how the assignments and the test schedules will be. So we have even the Telegram group, Telegram also. There's a link here. You can see. Just open the Telegram. In Telegram, like many different MPC, the older, I mean MPC or BIPC, whatever it may be. The older question papers are available. Previous year question papers are available along with the solutions. You can just mm, download the app, and then through the link also you can join our Telegram channel and then get the benefit of the previous year question papers, and along with that the solutions also. Okay. And yeah, there's a link as I told you, and see, the crash courses and the long term courses are available, and they're almost started. So you can just enroll your name, download the app, enroll the name, and then enjoy the benefits. Okay. And you can see we have online, even offline also. Online coaching is a regular basis, even like even if it is complete offline teaching in the colleges also, we will have online, and along with that offline also, right? So that is how the Spark Academy works. please do subscribe, and please download the app, subscribe to our YouTube, Telegram, Instagram channels. Okay, so this is the Spark Academy, this is how the Spark Academy works. Now we have like as I told you, we are going to have some simple, very important tips or tricks which are related to waves. As you all know that waves is very important lesson, like waves or wave motion. Yeah, one second. Yes, wave motion or waves, like how many types of waves or wave motions we have learned. Like initially when you have to start, we have progressive and stationary waves, isn't it, right? And these are the two types of waves. And I think you know the idea, like progressive waves again, we call them because they progress, they move forward. And these are of two types again, one is longitudinal wave and the other one is transverse waves. Okay, and stationary waves are those waves which will not move, they are stationary. When two waves combine together, which are traveling in the opposite direction, combine together, which are actually similar or with the same amplitude and the wavelength, when they combine together you get a stationary wave, right? And in progressive waves, crest and troughs are formed. I mean, longitudinal waves, we have compressions and rarefaction, and transverse wave, we have crest and trough. And in longitudinal wave, one compression and one rarefaction, one compression and one rarefaction will give you one wave. Okay, one complete wave we say. Whereas when it comes to, this is about longitudinal waves, and when it comes to the transverse waves are those waves in which crest and troughs are formed. Usually these transverse waves are formed when the particles vibrate perpendicular to the propagation of waves. Okay, longitudinal waves vibrates, longitudinal waves are formed when the particle vibrates parallel to the propagation of wave, and that is the reason why they are forming compressions and rarefactions. And transverse waves, when you take, they have crest and trough. Okay, crest and trough, and one crest and one trough will make one wave. Okay, so this is about longitudinal and transverse waves, which comes under progressive waves. Means these waves will be carrying the energy until and unless their energy becomes zero. Whereas when it comes to the stationary waves consist of, as I told you, these are the combination of two waves which are traveling opposite to each other. And these stationary waves are one will be moving forward and the other one will be moving in the backward direction. When they combine together, you get a stationary wave, and stationary waves will have nodes and antinodes. Okay, nodes are those with the zero amplitude, and antinodes are these are the antinodes with maximum displacement, right? So this is about the progressive stationary waves, right? No, in this lesson, especially when initially we start learning about the progressive waves, the wave equation, and then we go to the stationary waves and we see how the stationary waves are formed in the organ pipes. Okay, we have here two different types of organ pipes. Now, right, two different types of organ pipes, and these two organ pipes we are going to learn in this lesson today. Now coming to the topic weightage in intermediate, definitely one 8 mark question can be expected from this. IP point of view, one 8 mark question you can have from this lesson. And then when if it comes to the EAMCET and NEET, okay, you will have, one to two questions from this chapter. Okay, so this is about the topic weightage, and then as I told you, we are going to learn about the wave equation, how the waves are formed, and what are the formulas which are related to these waves and all. And we are also going to learn the formulas which are related to the stationary waves too. Formation of stationary waves, stationary wave formation in organ pipes. Okay, stationary wave formation in organ pipes. Organ pipes, that is two organ pipes we have. One is open pipe and the other one is closed. We will see that. Right, so this is about the points which we are going to cover. Now, as I told you, to learn about the wave, to know about the wave completely, we need to learn about the very important physical quantity which describes the characteristic of wave. The very important thing is wavelength. Okay, as I told you earlier in the beginning of this session, I told you that, like, when it comes to compressions or wave fraction, it is one or crust and trough. One crust and one trough will give you one complete wave, meaning from here to here, this is called as wavelength, which is represented by lambda, and the units of wavelength are meters or centimeters. Okay, like it's like distance only. Okay, this is about the wavelength. And then next we have amplitude. Now, when it comes to stationary waves, from here to here it is a wave. So, from here to here, this to this, one node to another node, or one antinode to another antinode, this is lambda by 2. Okay. And next physical quantity which describes the wave is amplitude. Okay. Amplitude is nothing but the maximum displacement of the wave. Maximum displacement, meaning if I draw two different waves here, you can just see which will have, you can just trace out which will have more amplitude. Just tell me from here to here, this distance is called as amplitude. Naturally, the second one will have more amplitude than the first one, right? So this is about amplitude. And the next one we have is frequency. Frequency is nothing but the number of waves per unit per given time. So frequency is represented by F, or you can also represent with N also. You can also represent with nu, whatever it may be, like this also you can represent. Frequency is equals to 1 by T. Okay, and 1 by T is nothing but the time period. I'll write here. Time period is nothing but the time taken by the wave to complete one particular oscillation. Like in terms of oscillation, or you can say in terms of circular motion, that will be the time taken by the wave to complete one circle is called as time period in circular motion. When it comes to the time period in vibrations or oscillatory motion, that is the time taken by the body to complete one oscillation, like from the extreme to another extreme, and again coming back to the extreme. One oscillation will be completed, and the time taken for this, that is called as time period. Okay, so 1 by time period is frequency, right? I can draw again two different waves here, like this is one wave and this is another wave. Now tell me which wave will have more frequency. So here this wave is having more frequency because in the given time, this number of waves are more here. So we call it as more frequency waves, right? So this is about the frequency. And coming to the units of frequency, unit of frequency is hertz, right? So this is about the frequency, and the next one we have time period we have discussed, and frequency also we have discussed, and velocity of the wave, you know, the wave with which the distance covered by the wave in a given time is called as velocity. You all know the formula of velocity is distance by time, or here the velocity of sound waves, especially when it comes to the sound waves, you can also find out the velocity of sound waves as v is equals to n lambda, where n is nothing but the frequency and lambda is nothing but the wavelength. Okay, so this is about the velocity. Usually velocity of sound in air is constant, and it is almost it varies depending upon the circumstances. It varies from 330 meters per second to 340 meters per second. It depends, right? So this is about the waves, I mean of the physical quantities which are related to the waves, right? And then like coming to the wave equation, as I told you, like, you know, this is y is equals to, what is the wave equation we have? Like y is equals to, means in by taking this amplitude and omega, one more thing, like, you know, we have another thing which is called as omega, which is wave frequency or wave velocity, we say. This is omega, and in terms of omega also you can write y is equals to a sine omega t plus phi. Phi is nothing but the phase difference. This is the simple equation what I wrote. Okay, it depends, like, you know, you can take means y is equals to a sine omega t plus phi. I mean, for two different waves, even the costing also can be involved. So this is about the waves, and now coming to the, I mean, as I told you, like, you know, we have open and closed pipes, isn't it? What is an open pipe? Open pipe is one in which two sides will be open like this, and here stationary waves are formed actually, you know. Two sides will be open and stationary waves are formed. One thing we have to remember here is stationary waves consist of nodes and antinodes, isn't it, right? So always the antinodes will be at the open ends and nodes will be at the closed ends. But here in an open pipe, two sides open ends, so you will get only the antinode like this. This is the fundamental thing we are getting. Okay, and what will be the length of this? Just the length from here to here, it is lambda by 4, and from, as I told you, node to node is lambda by 2, node to antinode lambda by 4, and another lambda by 4. Lambda by 4 plus lambda by 4 will be 2 lambda by 4, that is lambda by 2. Right? So this is in terms of open pipe. Now when it comes to the closed pipe, means like this is the fundamental thing what we have taken, but you can increase the number of waves also. Okay, usually why the stationary waves, there will be an air column inside this I mean inside the pipes, organ pipes, isn't it, right? So this air column makes the stationary waves to touch to the corners, and the waves which are going inside touch the corners and forms the stationary waves here. Now when it comes to the closed pipe, okay, like you have an experiment also, like, you know, to find the velocity of sound. There is an experiment here actually, by taking this resonating air column experiment is there, you can find out that, like, now as I told you, this is the closed pipe, one side open and another side will be closed, right? So as I told you, antinode and node at the bottom, like this it comes. This is the primary formation, fundamental one, and the next one also you can draw like this. Always antinodes here. Okay, what will be the length of this? length of this will be, this is lambda by 4, right? Isn't it? Node to antinode. And here it is lambda by 4 and this will be lambda by 2. So what will be the total length? Total length is lambda by 2 plus lambda by 4. So this is 4 lambda plus 2 lambda by 8. This is 6 lambda by 8. So 3, 2, 3 are 2, 4. 3 lambda by 4. So this is how you find out the length for higher orders also. Okay, so these are the open and closed pipes what we have. We'll just quickly discuss about a few problems what we have. Right, again I remind all of you to subscribe to our channel and get the benefits of it. And next here quickly, if we go 120, this problem, the first problem what we have is, the first problem what we have here is the frequency of the fork is 500 hertz. Okay, and the velocity is given as 350 meter per second, right? So now they are asking us to find out total distance travel for 125 vibrations. For 125 vibration, we need to find what is the formula we have actually. V is equals to simple formula, distance by time. Okay, distance by time. But time is equals to, for how many oscillations? Time is nothing but frequency only, no? We can write it as frequency, 1 by t is frequency. Frequency into distance. We want distance, isn't it? Distance is equals to velocity by frequency for 125 oscillations. This is 350 by frequency. How much they gave? 500 into 125 for 125 oscillations. So when you cancel this, like you get 5 tens, 5 sevens. 125 into 7 by 10 or 12.5 into 7 by 10 will be almost equal to 7 5 7 2 14 17 and 7 1 7 87.5. Yeah, the answer is 87.5 meters. We are finding out distance, isn't it, right? So 87.5 meters, right? So next one we have, a body is dropped into a deep well. This is this problem for this. Okay, for this I am just drawing. A body is dropped into a deep well. Sound of splash is heard after 4.23 seconds, meaning the body is going down and again the sound is coming back. Means the total time here is taken as 4.23 seconds. If the depth is 78.4 meters, okay, 78.4 meters, then he is asking us to find out velocity of sound. Okay, right. What is the formula for velocity of sound? First we'll find out the total time. Total time is while going down, that is time of descent. Okay, T1 is equals to under root of 2h by g. You know this formula, isn't it? While coming up, that is actually from velocity is equals to distance by time. You can write distance is equals to, this is T2, is equals to distance by velocity. So total time is equals to T1 plus T2, that is under root of 2h by g plus d by v. Now from this you need to find out the velocity, because total time they gave 4.23 is equals to under root of 2h by, h is 78.4, 78.4, 2 into 78.4 by 9.8 if you take, plus d by v. D is how much they gave? 78.4 by v we don't know, right? V we have to find out. If you substitute and then if you do it, then you will get V value is almost equal to 341 meter per second. Okay, so this is how we find out the velocity of sound in air, right? So this is the thing. And next one we have is, okay, so this is actually the standing wave formula. Standing waves are produced in 10 meters long stretched wires. The length of the wire is 10 meters. Okay, for how many segments? Means 5 segments are there. For 5 segments. Means each segment how much? 10 by 5. No, 2 meters. Each segment length will be 10 by 5. That is 2 meters. Okay, and the wave velocity he gave, the wave velocity is 20 meter per second, right? And the frequency we need to find out. So frequency we will find out, like each segment is 2 meters, right? So what is the formula for velocity? We have velocity is equals to frequency into lambda. Frequency is equals to velocity by lambda. Like each segment is 2, but one wavelength, length of the wave will be 2 segment, means 2 meters, 2 meters. One in that loop, no, 2 segments will be that. So 2 meters plus 2 meters, total lambda will be 4 meters. So this will be 20 by 4. So it will be 5 hertz. Okay. So 5 hertz is the answer for this question. Okay. So this is about this question. Next one we have is the equation, means this is the last example we just discussed. Y is equals to 5 sine 3x by 50 cos 450t. This is what they have given, isn't it? From this we have like a sine omega t plus that if you take omega t plus kx, if you take from that, means if you compare the original y equation to this, we get k is equals to 3 by 50 because kx, no, isn't it? And omega is equals to 450, isn't it? Yeah, omega is equals to 450 only. Yes, 450 only. So what is they are asking us to find out wave velocity. V they are asking us to find out. V is equals to omega by k. Right, this is the formula we have, that is 450 by 3 by 5. But I think this is in centimeters, isn't it, right? Yeah, this is in centimeters, but the answer is given in meters. So we need to convert that into meters. So you get 450, 450 into 5. This 5 comes up 3 into 100. So 5 ones are 5 twos are 45 by 6. 45 by 6, 6 are 36, 7 are 42. Like maybe this third 7.5 meter per second you will get. Okay, so this is how we will solve this, but we have even open and closed pipes also. We will discuss that particular thing in the next session. Okay. Yeah, we will discuss that particular thing in the next session about the open and closed pipes, and we also have beats and Doppler effect in this lesson. We'll continue doing in the next section. So thank you all for attending this, and again just a reminder, download the app and subscribe to different channels what we have, and get the benefits of all the courses and even in the fee also. Thank you so much for this session, for attending this session. Good day.